Let's look at this problem. Abby, Bridget, and 4 of their classmates will be seated in 2 rows of 3 for a group picture as shown. If the seating positions are assigned randomly, what is the probability that Abby and Bridget are adjacent to each other in the same row or the same column? This is a typical counting problem. So let's start from the easiest part. Since we are to calculate the probability of this event, that Abby and Bridget sitting together. So let's first calculate what's the number of outcomes that you can arrange all the 6 students for a group picture. That will be quite straightforward. If we number this as 1, 2, 3, 4, 5, 6, and we are to arrange or permute the 6 students for the group picture. Therefore, the number of possibilities is 6 factorial. So we bear that in mind. We'll use it later. Alright, let's look at the interesting part. To count the number of possible outcomes that Abby and Bridget are adjacent to each other, either in the same row or the same column. As we mentioned multiple times previously in similar counting problems, casework is always a good strategy when you consider a hard problem. In this situation, we certainly have 2 cases, right? So they are either in the same row or same column. Why do we want to separate the 2 cases? And the reason is quite simple. Because if the 6 students were to stand in a row, then as long as the number of the 2 students are adjacent, for example 2 and 3 or 5 and 6, then they're together. But in this scenario, because they were sitting in 2 rows, the number of them being adjacent doesn't necessarily mean they were sitting together. For example, 3 and 4, they are not together. And on the other hand, even if their numbers are not adjacent, they can still be together or next to each other. For example, 2 and 5, or 3 and 6, right? Therefore, the way to handle this has to be different for being in the same row or in the same column. Therefore, let's clean up the picture for the moment. So now, we want to separate this problem into 2 cases, right? So the case 1 would be in same row, right? In same row. Then this is supposed to be an easier case. Case 2 is in same column. Actually, neither case is terribly hard. The hard part is you separate the cases. And once after that, for each case, it will be straightforward to consider a mathematical model to do the counting. Alright, let's look at case 1. If they are in the same row, we have 2 choices. Either they were in the first row or they were in the second row. So 2 cases. And given that, the 2 students can be the first 2 or the second 2. Right? That's only 2 possibilities. Therefore, we multiply 2. And don't forget, these 2 students, Abby and Bridget, they can permute. One can be on the right or can be on the left. Therefore, we need to multiply 2 again. And are we done with this case? Certainly not, because we still need to permute the other 4 students to seat them in the rest of the 4 seats. Therefore, we have 4 factorial. We need to permute the 4 students. So that will be our case 1. How about case 2? For case 2, we need to seat them next to each other in the same column. Therefore, we have 3 choices. For each choice, there are 2 ways to permute the 2 students, Abby and Bridget. Abby can be in the front or on the back. So multiply that by 2. And then we have 4 more seats to seat the other 4 students, right? So in order to do that, we will do the same, times 4 factorial. Let's take this for example, right? We will number the 4 empty seats. Let's say we call that 1, 2, 3, 4. And Abby and Bridget, they are sitting here. We can just permute the other 4 students and have them sitting here. So we have so many cases. Therefore, the number of cases that Abby and Bridget sitting next to each other would equals 2 times 2 times 2 times 4 factorial plus 3 times 2 times 4 factorial. And this equals 8 times 4 factorial plus 6 times 4 factorial. And what we want to do is to calculate the probability, right? You certainly don't want to compute these numbers. You don't want to compute these products and then sum, because it'll be a waste of time. Remember, our ultimate question is the probability. So when we take the ratio, many numbers could be cancelled out. So we have 8 times 4 factorial plus 6 times 4 factorial and divided by 6 factorial. That equals 4 factorial. It will cancel with this 6 factorial. And 6 factorial has 5 times 6 left. So that's 5 times 6. And then that's 8 plus 6. So that's 14 over 30. And that equals 7/15. Therefore, our choice is C. If you like this video, please subscribe the channel and thumb up. If you have questions, please comment.